this video, we're going to do a review of solving simple one-step equations. In these simple one-step equations, there are certain things that need to happen. One, the variable needs to be by itself. That means we need to do the opposite of some type of operation that's going on in the equation to get the variable by itself. We need to cancel out those operations. If we're adding 6, we need to subtract 6, and so forth and so on. And whatever we do to one side of the equation, we have to do to the other side. Sides of the equation are created by the equal sign. The equal sign creates two sides of an equation. And if you decide to do something to one side, you have to do it to the other side.
So we're going to go over some examples. It's a great idea to put these examples in a notebook, in a composition book, somewhere where you can find them. You can go back and look at these examples when you need some help doing any worksheets that I give you. We're also going to make sure you know how to show your work when you do these problems. So we're starting off, like I said, with one-step equations. This is going to be a review. Many of you know how to do this, but we're going to go over it for those who may need a refresher. First thing, when they give you, or when I give you a worksheet, make sure you copy the problem down. And then from that point, you can start showing your work, what you're doing to solve this. Now remember, to solve any equation, you're going in the opposite direction. You're going in reverse. So you see what's happening in the equation. And in this equation, I am adding 5. To solve this, I need to do the opposite of adding 5. I need to subtract 5. And I need to do it to both sides. That means on both sides of the equal sign. And I put it up under what it needs to be combined with. A plus 5 and a negative 5 cancel each other out. So I show that. Then I do my work and I start bringing my work down, meaning I bring the x down. There's nothing left here because this canceled out. I bring down my equal sign. I combine these together. The signs are different. If the signs are different, I subtract, take the sign of the larger number. Positive 5. I circle it, put a box around it, underline it. There's my answer, and here's my work that I need to see. Example number 2. So write down example number 2. I write down the problem. I look at what's happening in the equation, and I do the opposite. This sign goes with this number. This is negative 5. What's the opposite of negative 5? Positive 5. What I do to one side, I do to the other side, and I put it up under what I need to combine it with. It can be put anywhere over here on this side. I just need to put it with what I'm going to combine it with. I bring down my x. I combine those together. They cancel out. I bring down my equal sign. I combine these together. The signs are the same. I add, keep the sign. X is equal to 15. So we've got 4 basic operations. We got adding, subtracting. We've got multiplying and dividing. You look at what's happening in the equation and you do the opposite. So let's look at example 3. Let's write down the problem. We look at what's happening in the problem. This is a division bar, so I'm dividing. The opposite of dividing is multiplying. Here is a great way to show that you're multiplying, and a great way to show that you're going to multiply to both sides. I'm going to put parentheses around the entire equation. That means I'm going to multiply everything in this equation by 5, because that's the opposite of dividing by 5, times 5. When I do that, it cancels this out. This 5 times 5 divided by 5, they cancel each other out, and you're left with an x. You bring down your equal sign. The 5 also needs to be multiplied over here on this side. 5 times 10 is 50. So parentheses are a great way to show your work of what you're doing to both sides, that you're multiplying really this entire equation right here by 5. This right here is my answer. So again, basic operations are adding, subtracting, multiplying, and dividing. To solve an equation, you do the opposite of those. These are pretty easy. Sometimes students have a hard time with this. If a number and a letter are beside each other, That's multiplying. So the opposite of multiplying is dividing. Here's a great way of showing dividing on both sides using a division bar. Because later on, you're going to get fractions as answers. And most math teachers, especially in high school, are going to want you to write your answers as fractions. The only time you're not probably going to write your answers as fractions is when you're in geometry. This is 5 times x. The opposite of multiplying by 5 is dividing both sides by 5. Again, the purpose of this was to cancel that black 5 out right there. Bring down my x is equal to 10 divided by 5 is 2. This is how you show your work on the 4 basic operations. Make sure you do it to both sides. Here's how you show multiplying on both sides. Here's how you show dividing on both sides. Use a division bar. Let's look at example number 5. Example number 5, I need to determine what I need to do to solve this. I always look at where my variable is, and I look at numbers over there on that side of the equal sign that I need to get rid of. The number I need to get rid of over here is a -3. The way I get rid of that number is by doing the opposite of -3. The opposite of -3 is +3. I'm going to write my problem down. The opposite of -3 is +3. I put it right up under it because that's what I want to cancel out. And if I add 3 to one side, I need to add 3 to the other side. This cancels out. This is a plus x. I don't have to write pluses in front of things. Is equal to, the signs are different. If the signs are different, I subtract. 11 minus 3 is 8, and I take the sign of the larger number. I circle it, put a line under it, put a box around it. So whatever number's over here, if it's right beside the x, that's multiplying, but look, there's a plus that's separating it. That means I need to get rid of this number, and the opposite of this number is this -3. The opposite of that is +3. So for it to be multiplying, it has to be right by the x, and there's a separation there. That sign has separated it. Let's look at example number 6. Example number 6. I'm going to write down my problem. I'm going to look and see what operation is taking place in the equation. This is multiplying. Well, the opposite of multiplying is dividing because this 4 is right by this x. Notice it's not separated in our other example. So to show division on both sides, I'm going to do a division bar on both sides and divide both sides by 4. Those 4 cancels out. Bring down my x, bring down my equal sign. 7 divided by 4. If I took a calculator out and did that, it would not come out to be a whole number. They're more than likely going to want you to write fractions. This is already written as a fraction. It's okay for the top number to be bigger than the bottom number. That's just an improper fraction. My answer is simply 7/4. I don't have to do anything else here. Let's look at this one. Same thing. 12 is right by that x in example number 7. 12 is right by the x. So that means those things are being multiplied together. The opposite of multiplying is dividing. I'm going to divide both sides by 12. The 12s cancel out. X is equal to, all fractions, and this is a fraction, always have to be in lowest terms. I need to find a number, the biggest number, that will go into 2 and 12. And I divide both of those by that number. Divided by 2, divided by 2. 2 is the biggest number that will go into both of those. I divide the top by 2 and the bottom by 2 and see what I have left over. 2 divided by 2 is 1. 12 divided by 2 is 6. My answer is 1/6. Always put a fraction in lowest terms. Now some people think, well, this is not in lowest terms, I didn't change it to a mixed number. Changing something to a mixed number is not putting it in lowest terms. The instructions have to say, write it as a mixed number, write it as an improper fraction. The instructions didn't say write it as either one. So you can leave it as an improper fraction. It's okay. But you can't leave it where it's not reduced, where there is a number that will go into the top one and the bottom one. Always reduce your answers. Example number 8. Again, I'm multiplying because this negative 14 is right by the x. The opposite of multiplying is dividing. I'm going to divide both sides by negative 14. These cancel out because a negative divided by negative is a positive. And the same thing here, a negative divided by negative is a positive. Not only do I need to reduce it that way, I also need to find the biggest number that will go into 7 and 14, and that is 7. I need to divide both the top and the bottom by 7. 7 divided by 7 is 1. 14 divided by 7 is 2. And remember, a negative divided by negative is a positive. My answer is going to be positive 1/2. Let's look at an example like number 9. Again, this negative 8 is beside that x. That means I'm multiplying. The opposite of multiplying is dividing. I'm going to divide both sides by negative 8. These negative 8's cancel out. I'm left with x is equal to. Again, I'm going to reduce the numbers. I'm going to worry about the sign in a minute. 2 will go into the top and 2 will go into the bottom. 2 divided by 2 is 1. 8 divided by 2 is 4. 1/4. Is my answer going to be positive or negative? Well, I go back and look right here. A positive divided by a negative is a negative. Do not leave the negative sign in the bottom. It can be in the top. It can be right beside the division bar, but don't leave it in the bottom. So simply put it out here in the front, because 1/4 represents one number. 1/4 is negative, not just a 1 and not just a 4. 1/4 is negative. Last example, and it's something called standard form, so I'll make sure I write this down. Standard form. From this point on, all equations need to be put in standard form. That means the variable needs to be on the left side. And if it's not on the left side, you need to switch the entire equation around. At some point, I can switch it around at the beginning, or I could switch it around at the end. I'm simply going to always switch this equation around at the very beginning. So as soon as I see an equation that looks like this, where the variable is not on the side it's supposed to be on, I'm going to take everything over here and put it on this side of the equal sign, and take everything that's over here and put it on this side of the equal sign. I'm simply going to switch this around. I'm going to take what's over here, put it over there, take what's over here, put it over there. And when I switch it around, it looks like this. Then I begin to solve this. Then I look at what numbers I need to get rid of. Always switch this around. Never leave the variable over here on this side. We need to get in the habit, because we're going to start putting equations in standard form and everything needs to be in standard form. Make sure the variable is over here on the left side. Then start to solve this. Then look at what numbers you need to get rid of. These numbers are not right beside each other. They're separated. The opposite of negative 5 is positive 5. I need to get rid of that by adding 5 to it. I need to get rid of this negative 5 by adding 5. And if I do it to one side, I do it to the other side. These cancel out. I bring down my x. I bring down my equal sign. 25 plus 5 is 30. So if the variable is not on the left side, switch the entire equation around to where the variable is on the left side, and then start solving it.